Hello guys, this is Dave. Today we are going to discuss about the motion of center of mass, collision of particle with respect to the center of mass, and you will see how the frame of reference changes the whole equation of collision. Okay, when we look the collision from the point of view of center of mass. First of all, I want to assume a system of two particles. Say this is m1 and this is m2. Okay, and I choose a reference point which is O, and it is given that from O the radius vector of m1 is r1, from O the radius vector of m2 is r2, and there is a line joining m1 and m2. Obviously the center of mass must lie somewhere here, so let us say the radius vector of center of mass from O is r. Alright, let us designate this point as P and this is A and B. Alright, now from this point O, we can calculate R. What was RCOM? The standard basic definition that I told you was summation mi ri divided by summation mi, right? I goes from 1 to n. Since O is taken here, so we will choose the reference point O and R will be chosen accordingly. So R would be equal to m1 and r1, right? This is vector, all these are vectors, plus m2 r2 divided by m1 plus m2. So this is the center of mass, or we can say the point P from the origin O. Alright, we have taken the frame of reference over here, so we have arrived at this coordinate. Now I am just going to transform this frame of reference. We take the frame of reference as P now. So from P, which is the center of mass, the position vector of m1, I define it as r1 dash. Okay, and from P, the position vector of m2, I define it as r2 dash. Alright, so I want to find the value of r1 and r2, because right now we are seeing from the center of mass. Okay, so first we apply the triangular law. So you see, in triangle OPA, vector law will apply. So the vector law will be applied as follows: OP plus PA would give OA. Alright, this is a triangular law of vector. So what is OP? OP is R. What is PA? PA is R1 dash. And what is OA? OA is R1. Alright, this is the equation. Now I'm just writing down here, R1 dash is equal to R1 minus R. Okay, R, I just calculated R here. Alright, this is R, so we just substitute the value of R over here. We have R1 minus M1 R1 plus M2 R2 divided by M1 plus M2. Okay, so R1 dash we get as, this will be equal to M2 times R1 minus R2 divided by M1 plus M2. Okay, this is R1 dash. Alright, similarly in triangle OPB, we have OP plus PB. This will give OB, and OP is R, PB is R2 dash, and OB is R2. So we have R2 dash equal to R2 minus R. Just substituting the value of R over here, we have R2 dash would be equal to R2 minus M1 R1 plus M2 R2. This gets divided by M1 plus M2. Okay, so what is R2 dash? R2 dash is M1 times R2 minus R1 divided by M1 plus M2. Okay, so I'm doing a manipulation over here. I multiply this with M1, so this will be M1 M2 times R1 minus R2, and I just multiply this with M2, so this will be M1 M2, this is M2 into R2 minus R1. So I just add now M1 R1 dash plus M2 R2 dash. What will be this? Since this is common, m1 m2 upon m1 plus m2 is common, we will take this as mu times r2, and r2 gets cancelled over here and r1 gets cancelled. So this is 0. This will be 0. So this is the original figure. M1, M2, this is R1, this is R2, this is R. This is R1 dash, R2 dash. So I have arrived at a conclusion that M1 R1 dash plus M2 R2 dash is equal to 0. This is the basic concept of center of mass, where moments of mass is 0. Because I have taken this as moment because moment of force was r cross f, which was torque, right? But that was vector, because f is a vector, r is a vector, and torque must be a vector. But here it is a vector, yes, but m1 is not a vector. Here m1 and m2 are scalars, and there is no cross product. Okay, so just using the analogy of torque, I have written this as the moment of mass. So moment of mass with respect to the center of mass frame is 0. Alright. So what was r? R was m1 r1 plus m2 r2 divided by m1 plus m2. Okay. This equation of moment of mass being 0 is with respect to the COM frame. Alright. Remember this. And this is with respect to the origin O. Now this is the position of COM. What will be the velocity of COM with respect to O? I just differentiated, so we will have m1 v1 plus m2 v2 divided by m1 plus m2. Since m1 plus m2 is common, it will go out, and m1 times dr1 by dt will be v1 and dr2 by dt will be v2. This is the velocity of center of mass, yes, but with respect to origin O. Okay. This is the velocity of center of mass, yes, but this is with respect to origin O. And velocity of m1 with respect to O is v1, and m2 with respect to O is v2. Okay. Now, what will be the velocity of mass m with respect to the center of mass? This is r1, this is r2, this is m1, m2, this is the line, and this is r1 dash, and this is r2 dash. Since the coordinates of m1 is r1 dash with respect to point P, which is the center of mass, so we just differentiate it. But first of all, we will have to find out what was r1. R1 dash was actually this was, since this was m1 will get cancelled out, so this will be m2 divided by m1 plus m2, right, into this will be r1 dash plus r equal to r1, and this was r1 minus m1 r1 plus m2 r2 by m1 plus m2, right? m1 gets cancelled. This will be m2 into r1 minus r2. Okay, so we just differentiate this. So you see dr1 dash by dt, this will be m2 by m1 plus m2 into v1 minus v2. Okay, so this is the velocity of particle of mass m1 with respect to point P. This velocity is not with respect to O, this is with respect to point P. Okay, so the velocity of particle mass m1 with respect to the center of mass is this. Okay, I can take this as v1 dash. Similarly, v2 dash, using the analogy, and dr2, this will be dr2 dash by dt. So this will turn out to be m1 by m1 plus m2 times v2 minus v1, right? Okay, so m2 by m1 plus m2 times v1 minus v2, this was v1 dash, and v2 dash is m1 by m1 plus m2 times v2 minus v1. Now I just multiply this by m1, so this will be m2 m1 upon m1 plus m2 times v1 minus v2, and I just multiply this by m2, so this will be m1 m2 divided by m1 plus m2 times v2 minus v1. I just add these. This gets out because this is common. v1 minus v1 gets cancelled, v2 minus v2 gets cancelled. So we see m1 v1 dash plus m2 v2 dash is equal to 0. So what do we conclude here? We conclude that the net momentum of system, okay, net momentum of system with respect to center of mass is 0. Okay. So we conclude that net momentum with respect to the center of mass is 0. Okay, this is the final conclusion I have drawn. Now we just do a problem. Say this is m1 and say this is m2. Say this has initial velocity v2 equal to 0 and say this has initial velocity v1. Alright. And this is a elastic collision which will occur. Alright, and the final situation is something like this. m1 has velocity v1 dash and m2 has velocity v2 dash. Okay, this is the question. Now you see v1 dash and v2 dash are in the these velocities v1 dash v2 dash with respect to ground. Okay, now I want to find out v1 double dash and v2 double dash, which are velocities with respect to the center of mass. Okay, so how will we do this problem? First of all, since this is elastic collision, kinetic energy shall be conserved, and also there is no external force, so momentum is conserved. Okay, so using, first of all, we take it from the ground perspective. We have the initial momentum as m1 v1, pi would be equal to pf, right? Initial momentum equal to final momentum. So we have initial momentum as m1 v1, since this is 0, final momentum as m1 v1 dash plus m2 v2 dash. Okay, and we have initial kinetic energy half m1 v1 square equal to final kinetic energy m1 v1 dash square plus half m2 v2 dash square. Okay, this is square. Alright, we have two equations and two unknowns, v1 dash and v2 dash, because v1 is given over here. Okay, so these were the two equations. I am solving them right now. We first square the first equation. This is the first equation, this is the second. Okay, we have m1 square v1 square equal to m1 square v1 dash square plus m2 square v2 dash square plus 2 m1 m2 v1 dash v2 dash. Okay, and now half gets cancelled over here. In equation 2 we have m1 v1 square equal to m1 v1 dash square plus m2 v2 dash square. Okay, in this equation we multiply it with the m1. Okay, so this will be m1 square, this will be m1 square, and this will be m1 m2, right? Now this is equation 4 and this is equation 3. Okay, now we subtract equation 3 from equation 4. So we have, this will get cancelled out, this will get cancelled out. We have m1 m2 v2 dash square minus m2 square v2 dash square equal to 2 m1 m2 v1 dash v2 dash. Okay, 1 v2 dash gets cancelled out and we have m1 minus m2 times m2 equal to 2 m1 m2 v1 dash. Alright, and this is v2 dash. Okay, m2 m2 gets cancelled out, so we have v2 dash equal to 2 m1 divided by m1 minus m2 v1 dash. Putting this in the first equation. Alright, this value of v2 dash equal to 2 m1 upon m1 minus m2 v1 dash will put in the first equation. So first equation was m1 v1 equal to m1 v1 dash plus m2 v2 dash, and v2 dash was 2m divided by m1 minus m2 v1 dash. Okay, and this was 2m1, right? So we have m1 v1 equal to m1 v1 dash plus m2 times 2m1 divided by m1 minus m2 v1 dash. Okay, so this will be m1 square v1 dash plus m2 twice m2 m1 v1 dash minus m1 m2 v1 dash divided by m1 minus m2. This will be cancelled and this will remain as m1 square plus m1 m2 divided by m1 minus m2 times v1 dash equal to m1 v1. m1 gets cancelled out and we take the expression over here. We have v1 dash equal to m1 minus m2 divided by m1 plus m2 times v1. Okay, this is the velocity v1 dash. This is the velocity v1 dash after collision, yes, but this is the velocity with respect to ground. This is not the velocity with respect to center of mass. Just remember this. This v1 dash velocity is the velocity with respect to ground after collision, and this v1 is the velocity with respect to ground before collision. Okay, and what will be v2 dash? v2 dash will be m1 minus m2 will get cancelled out, so we have 2 m1 by m1 plus m2 into v1. Alright, this is the final velocity with respect to ground. Alright, now let us move to the frame of center of mass. Okay, this is m1, this is m2. Initially m1 was moving with velocity v1, right, and m2 had velocity 0. So this was with respect to origin. Okay, this is r1, this is r2, and this is the line joining, and this is the center of mass P, which has r coordinate. As I already told you earlier, the velocity of center of mass with respect to origin was m1 v1 plus m2 v2 by m1 plus m2. So with respect to origin, m1 has v1 and m2 has 0. So v with respect to O is m1v by m1 plus m2. Okay, and m1 has a velocity with respect to okay, so this was r1 dash and this was r2 dash. What was r1 dash? r1 dash was r1 minus r. And what was v1 dash? Let me call it as r2 double dash, r1 double dash and r2 double dash, because this will get confused with v1 dash was the velocity final with respect to origin, na? So I am considering this velocity initial velocity. This is initial velocity, okay, before collision, okay, with respect to center of mass. Alright, and v1 dash was final velocity with respect to origin. Alright, so what will be v1 double dash? v1 double dash will be v1 minus v, because differential of r1 will be v1, so v1 minus v, and v was this, so this will be m1 v1 by m1 plus m2. So what is v1 double dash? v1 double dash is minus m2 v1 by m1 plus m2. Okay, so we have got v1 double dash over here. This is the initial velocity before collision. Okay, what is v2 double dash? Similar would be the v2 double dash. v2 double dash would be equal to v1 minus, no sorry, this will be v2, yeah, v2 minus v, right, and v2 was 0. With respect to origin, the mass m2 had 0 initial velocity, so this will be minus v. So just simply negative of this, so v2 double dash would be equal to minus m1 v1 by m1 plus m2. Okay, so v1 double dash was minus m2 v1 by m1 plus m2, and v2 double dash is, sorry, this was positive, this is negative m1 v1 by m1 plus m2. Alright, so just I am doing some manipulation over here. I am multiplying this by m1, so we have m1 m2 upon m1 plus m2. I am multiplying this by m2, so just we add, this gets out common, v1 even gets cancelled, so we have m1 v1 double dash plus m2 v2 double dash is equal to 0. Alright, so you see the total momentum before collision with respect to the center of mass is 0. Okay, since total momentum is 0, P initial is 0, P final will also be 0. Okay, since no external force is acting, I have already stated no external force is acting, initial momentum has to be equal to final momentum. If initial is 0, final has to be 0. Alright. So, I consider the final velocities after collision with respect to center of mass as v1 triple dash. This is final velocity after collision. Okay. With respect to point P COM. Okay. And I consider v2 triple dash as final velocity after collision. Alright. So, since final momentum is 0 as initial is 0, I already told you net external force is not acting here. No external force is acting, so initial and final are same. So, if initial is 0, final has to be 0. So, final momentum will be m1 v1 triple dash equal to, plus m2 v2 triple dash equal to 0. Right? Okay. So, you understood these things. So, m1 v1 double dash plus m2 v2 double dash equal to 0, m1 v1 triple dash plus m2 v2 triple dash equal to 0. Now, since elastic collision is there, Ke initial would be equal to Ke final. Okay. So, we have half m1 v1 double dash square plus half m2 v2 double dash square equal to half m1 v1 triple dash square plus half m2 v2 triple dash square. Alright. From this equation we have v1 double dash equal to minus m2 by m1 v2 double dash, and from this equation we have v1 triple dash equal to minus m2 by m1 v2 triple dash. Just I am substituting the value of v1 and v1 double dash and v1 triple dash over here. So we have half m1 times m2 by m1 square v2 double dash square plus half m2 v2 double dash square equal to half m1 times m2 square by m1 square v2 triple dash square. This is 2, okay, and plus half m2 v2 triple dash square. Alright, m1 gets cancelled out, v2 we can take outside common, half gets cancelled, and we are taking m2 also outside, m2 times m1 plus m2, okay, divided by m1 times v2 double dash square equal to, similarly here m1 gets cancelled out, m2 is taken outside, and v2 triple dash is also taken outside. So m2 times m1 plus m2 divided by m1, and this is v2 triple dash square. This whole thing gets cancelled out, and we have v2 double dash square equal to v2 triple dash square. So we arrive at a conclusion v2 double dash equal to v2 triple dash, and from this, since v2 double dash and triple dash are equal, this can be divided and we get v1 double dash equal to v1 triple dash. So you see, we have arrived at this equation. The velocities of initial and final are same with respect to the center of mass. Okay, I have derived this properly, you can see. So velocity, so initial and final velocity with respect to COM is same. Okay, and v2 double dash I have already given you the value, v1 double dash I have already given you the value, v1 triple dash and v2 triple dash have been found out, and you can quite clearly see they are different from v1 dash and v2 dash. Alright, this is what I want to emphasize by the frame of if we change the frame of reference, the velocities have changed, the magnitudes of velocities have changed. So this is what I want to emphasize. If it is being asked from the perspective of center of mass, then velocities are v1 triple dash, but if and v2 triple dash, but if it is being asked from the perspective of the origin O, then velocities are v1 dash and v2 dash final. Okay, just remember this is a very important concept. So guys, this was my analysis. Next video would be of moment of inertia and rotation. Okay, please like, view, review, recommend the course. Alright, bye for now. Thank you.